G'day everyone. I'm going to, talk about some of the theory behind what Connie's been talking about. Air circulation fans is not something that I've personally been able to investigate or research or be involved with, but it's a really interesting concept that they've been working on for a while. And what I've been working on lately is combining some of the models and things that I've developed over the year to estimate how much water the birds put on the floor, how litter dries, and the conditions required for litter drying to be improved. And then we've been getting some data from farms lately. So I've been able to put all of that together and then tweak it a little bit to see what the possible effect would be from a theoretical point of view on drying litter using circulation fans. So that's going to be the focus of this presentation. Before I get started, I just want to thank AgriFutures and Department of Agriculture in Queensland for supporting this research, and also thank you to the growers who have provided ventilation data and litter samples so that we could do our investigations and try and understand what's going on a little bit better. So this is a bit of a recap of the last webinar that I presented. So the things that are required to evaporate water from the litter are firstly moisture in the litter. Bringing the water to the surface will help to improve getting rid of it. But also what we find is that the wetter the litter is, the more water that you remove. I mean, it all sort of makes sense. But if you have really dry litter, it's really hard to get that last bit of water out of it. Adding heat to the air into the litter will improve evaporation rate. Airspeed, which is mostly the focus of this presentation, increasing the airspeed will increase evaporation, and having low relative humidity. So that sort of goes hand in hand with adding the heat, but it also requires ventilating the moisture out of the shed to try and keep the humidity low. And that's one of the things that Connie was focusing on just before. So if you want to maximise litter drying, what is it best to do? Is it best to till the litter, turn up the heat, or turn on more ventilation fans? Or would it be worthwhile considering what the effect of air circulation with some airspeed, what that would do for the evaporation rate? So first of all, bringing the moisture to the surface. If the moisture is not at the surface, you won't remove it. It's a bit like if you had a wet towel and you throw a dry towel over the top of it, the wet towel will just stay wet underneath it. You've really got to get that the water to the surface so that it can be removed. Tilling the litter increases the rate of evaporation a lot. So compared to just normal friable litter, turning it and bringing the moisture to the surface will increase the rate of water loss by about 4 to 5 times for the first 4 to 6 hours. And that's it's important to understand that, because if you're going to till the litter, you really need to do it at a time of day when the conditions are going to be right to actually remove that water. So tilling the litter in the sort of mid-morning to lunchtime is best, so that you've got the afternoon to try and remove the water before the ventilation starts to reduce for the evening. But the effect of tilling the litter goes on for longer. So for up to about 12 hours, the rate of evaporation is going to be about 2.5 times what it would be if you didn't till it. And it keeps going up to about 1.5 times. So you're still getting 50% more water off the floor for about the first 20 hours after tilling. And then after 24 hours, the rate of water loss seems to return back to where it would have been if you hadn't tilled. But that assumes that there's no further movement or stirring of the litter, which of course, when I did these experiments, I didn't have chickens stirring the litter, but in the sheds you do. So I suspect that the effect of the tilling will actually be longer than the first 24 hours. If you have caked litter, the increase in water loss is far more. So caked litter has the evaporation rate of about 1/3 of friable litter, So if you stir up until caked litter, you're likely to get 12 to 15 times the water evaporation for the first 4 to 6 hours, about 7 times the amount of water up to about the first 15 hours, 12 to 15, and you're still going to be getting 4 to 5 times the water loss for the first 20 hours. And because you've made that litter friable, if the chickens are able to keep working it, you're going to continue to see the benefit of stirring the litter or the chickens working the litter. Because their feet are engaging with it, they're continuing to turn it, work it, dig in it, bury in it. When you turn the litter over and it was caked and it's then friable, the chickens seem to enjoy it and they engage in it. And yeah, so it's far more likely, I think, to get a much longer effective water evaporation if you can get it tilled so that the chickens can keep working it. Adding heat, so the heat can come from the birds or the heaters, but of course earlier in the batch the chickens don't make a whole lot of heat, so you need to use the heaters. And what we rely on is the rule of thumb that increasing the air temperature by 10 degrees will reduce the relative humidity by about half. But you can't just warm the air, you've got to get the warmth into the litter. So from a theoretical sort of point of view, so this is using some calculations on water loss or water evaporation. The orange line there is if you heat up both the air and the floor. And if you heat both of them up, what you find is that the rate of water loss, which is what's on the vertical axis, increases a lot as you increase the air temperature. But if you increase the air temperature but not the floor temperature, you actually really don't get any increase in the water evaporation. Now, this is sort of theoretical, and it's difficult to say that this is actually going to happen in real life because the warmth from the air is going to heat up the floor slightly. But it means that you can't just sort of bring in the air, heat it, and blow it out because you need to give it time to warm the floor up. Using circulation fans, as Connie showed, helps to get the heat from the ceiling down to the floor. So the more you can bring that heat down, the warmer the floor is going to be and the more water you're going to evaporate from the floor. So low relative humidity is another concept that Connie was talking about. And she's saying that we're aiming for 50 to 60% relative humidity. In order to do this, you need to ventilate the water out of the shed. I'll go to the next slide here. This big chart here, there's lots of numbers here, but if you look along the top, you can see the temperature of the air coming into the shed and the relative humidity. So this is your outside conditions. So if we just have a look at an example now, so if we say that the outside air is going to be about 10 degrees, which is what our mornings are like up here at the moment, and it's 100%, so 100% relative humidity, so it's foggy outside. If you can heat that air to 21 degrees, the air will reduce in relative humidity to about 50%, which is what we're aiming for. So you don't need to heat it a lot, especially when it's cold outside. Summer's actually probably more of an issue because when you have warmer outside temperatures, even if the relative humidity is lower, you need to have much higher temperatures inside the shed. And so when you look at this, you kind of think, but hang on a sec, my sheds are 20 degrees inside now. We're having this sort of 10 degrees and 100% relative humidity in the morning. How come my relative humidity is not 50%? And one of the reasons for that is that it's picking up the moisture from the floor. So as it adds that moisture into the air in the shed, your humidity goes up in the shed. And that's why it's so important to ventilate it out. But what this chart does show is that when you bring the next lot of air in and you warm it up, you're then reducing that back to 50% and you're repeating the cycle. So this is why it's so important to ventilate enough to get the moisture out of the shed and bring fresh air in for it to be warmed up and be allowed to continue to take the water out of the floor. Now let's start looking at the airspeed. So airspeed is proportional to evaporation. The more airspeed you get on the floor, you'll get an equal increase in the amount of evaporation. Connie was talking about, I think, conserving heat. So With the airspeed, what it does is it mixes the air around the shed, so you get a more uniform temperature throughout the shed. And what this does is it prevents having a high temperature at the ceiling. And because when you have high temperature at the ceiling, it's a lot more of the heat's going to escape through the insulation and out of the shed. You want to make use of the heat that you've just created and paid for. So by having the air circulation, you actually bring that heat down and you stir it up in the shed. So from a theoretical point of view, these two lines here show two different calculations that I can use or have used. One of them is just based on evaporation theory, and the other one is based on experimental results in a lab that I've done in the past with litter. So what we see is that they're both fairly similar. We both see a linear trend with them. So when you increase the airspeed, you increase evaporation rate. What I don't really know at the moment is the airspeed at the floor during side vent mode. But I'm going to have a guess that it's about 10 centimetres per second. And looking at Connie's smoke during her presentation, I think it's probably a reasonable guess. But this air circulation concept relies on increasing the airspeed to about 0.8 metres per second. So what we see when we do that is that it would increase the evaporation rate by about 50 or 60%. So that's a continuous improvement, especially early on in the batch. So I then wanted to apply some of this theory using ventilation and shed data from a real farm. So we've got real temperature and humidity conditions, real ventilation rates, real amounts of water going on the floor. And so the next couple of figures are going to be results from this simulation of what the litter moisture content and water loss would be like. So the farm that I got the data from was in Brisbane, and I've got 3 batches worth of data going from September to March. So it's mostly over summer, and hopefully coming up soon, I'll get some more winter data, and then we can reevaluate how all of this works out. I've assumed that wood shavings have been used for each batch, and I know there was a question to Connie about the bedding used. What we would see with the wood shavings is that it will increase the moisture content much more quickly than it would with reused litter because the wood shavings don't have the same water holding capacity. And with the amount of water, remember right from the start we said that you have to bring the water to the surface. By having wood shavings with higher moisture content, you're actually likely to get higher evaporation rates, relative evaporation rates. So wood shavings at the start of a batch, you're more likely to get a greater reduction in the moisture content with the same amount of ventilation effort. We're going to assume that the circulation fan system's been put in and we're getting 0.8 metres per second at the floor. But the data that we've got here, there'll be no changes in the temperature or humidity settings. It'll just be as it was. When I applied the evaporation models to the real shed data, and then added the circulation fans, what I saw was that at the start of the flock, we were getting about 60% improved water removal from the shed and from the litter. And that lasted, it was a decreasing benefit for about the first week. And then after that, it was about a 10 to 20% increase in water evaporation rate. The orange and green lines show what the modelled litter moisture content would have been, with the orange lines being the normal situation and then the green line being a shed with the circulation fans installed and having that higher airspeed. So the biggest benefit is really at the end of brooding. We can see that the litter moisture content is reduced from about 25 to 30%. Down to about 15 to 20%, 17 to 20%. And then that can have a really big effect on the ammonia production, the commencement of caking, and very likely the start of footpad dermatitis and other issues for the birds as well. The benefit of the circulation fans decreases, of course, as you go through the batch, because after about the first 3 or 4 weeks, there's so much ventilation going on in the shed that the airspeed that you would add with the circulation fans is it's minimal, or the benefit of the circulation fans is minimal. And so towards the end of the flock, it doesn't actually make any difference because the shed's ventilation is actually producing enough airspeed. So I would suggest, based on this, that you probably don't need the circulation fans after the first 2 or 3 weeks or 4 weeks. But the benefits to the litter moisture content continued up until first thin out. So just comparing, so collating the data from all 3 of the batches again, this is these dots sort of indicate how much drier the litter was compared to the shed without any circulation fans. So towards the end of brooding, the litter was only about 70% of the evaporation, 70% of the moisture content of the shed without circulation fans. And I think this really kind of nicely supports the data that Connie has collected in the past, which demonstrates this. In Connie's presentation, she showed that the dry litter doesn't really get drier, but certainly the wetter litter becomes drier, and that's how she achieved the more uniform litter moisture content throughout the shed. And I could simulate that in this with this model as well. I set the litter moisture content to 15% regardless of what happened beforehand, and we see less we see less of an improvement with the circulation fans. But if we increase the litter moisture content to 30 or 45% consistently, then you see a much bigger effect for longer by having the circulation fans. So it really does help to improve the uniformity of the litter within the shed, or it's very likely to. So I'll just wrap up now. Using simulations based on theory and our previous experimental results on litter moisture content, having air circulation fans that generate some decent airspeed on the floor will definitely contribute to drying the litter and providing more uniform litter moisture content. But relative humidity control and ventilating the moisture out of the shed are still essential. Like I said right at the start, I haven't actually been involved in being able to use these circulation fans, although I would be very interested to. If anyone is keen to give it a try in their shed, I'd like to be involved in that. Some things that we really need to do to try and improve our understanding of this is firstly to measure the airspeed in sheds now when they're in side vent mode, and I've got some plans in place to do that. It'd be interesting to look at ventilation data from other regions to see what the possible benefits are, particularly in the southern regions where you do have the cold, wet winter. We need to look at the air circulation fans that we've got available to us in Australia and develop some strategies for how we would install them in the sheds, given that a lot of our sheds have still got ceiling baffles. But that's, and I'd also like to evaluate whether adding the circulation fans will reduce the ammonia concentration at the litter. I didn't realise Connie actually had data for that already, and I think it demonstrated that quite nicely, that it will help to dilute the air, but also reduce the ammonia being produced in the litter. So just sort of wrapping up, in general, increasing the airspeed is going to increase the water evaporation and therefore get drier litter. But it's still going to need a combination of heat and relative humidity control and probably tilling to really maximise the effect of it. So thank you very much for your time today. If you have any questions, I'll answer some of them now, but please feel free to get in touch with me. And I'd just like to remind everyone that there are some really great videos that have been put onto the Extension Oz website about heating litter, relative humidity control, and other topics to do with litter management. So just follow the links, and thank you very much. Back over to you, Felicity.
Mark, without stirrer fans in the shed, what's the best way to heat the floor?
I don't know if there is any better way to heat the floor other than probably using the radiant type heaters because they actually, they project the heat down to the floor. one of the problems with the space heaters is that all the air goes up to the ceiling. It sort of comes out of the heater and rises. Circulation fans of any description that helps to get the heat back down to the floor will help to heat the floor up. Otherwise, it just takes a lot of time and a lot of gas.
Have you had experience with using underfloor heating, and if it dries the litter out more?
I don't have any experience with underfloor heating. From a theoretical point of view, if you heat the floor, you will get, that's where most of that increase in the evaporation rate comes from, when you're heating the air and heating the floor. If you don't heat the air and you just heat the floor, you actually get pretty much the similar evaporation rate. So getting the heat into the floor is far more critical than heating the air. But then there's limits, of course. You can't have cold, wet air in the shed, otherwise you'll just get condensation and it'll rain back down on the floor again. But yeah, heating the floor is certainly important.
And have there been any studies done on managing litter for naturally ventilated sheds?
Not that I'm aware of, not recently. With naturally ventilated sheds, you're really at the mercy of the conditions outside the shed and how well you manage your vents and the design of the shed. Yeah, so I haven't seen any research studies on naturally ventilated sheds anytime recently. How
long were the stirrers on for?
In the simulation that I did, they were on constantly. But I had to do some maths in there to say if the airspeed was greater than that 0.8 metres per second, then effectively the stirrer fans were turned off. I'd be cautious about turning fans on and off too much, especially in the first 3 or 4 weeks. Like Connie was talking about drafts, and one of the problems with turning them off is that you allow the hot air to rise and the cold air to sink, and then when you turn the fans back on, then you feel the draft. If you have them running constantly and getting that air mixing constantly, the draftiness of the shed will be a lot less.
Mark, does bringing your air into the shed through mini vents up through the roof do the same thing as stirring fans?
If they were running constantly, it probably would. Possibly not the same air speeds, or definitely not the same air speeds as what you would achieve with these stirring fans. The problem is, particularly early in the batch, you've got your duty fans cycling on and off. So whenever they turn off, the airspeed stops. And to achieve the amount of airspeed required for litter, using your exhaust fans to drive the air coming in through the mini vents, you'd just be extracting the heat all the time. So the benefit of the stirrer fans here is that you can shut the shed up when you don't need to exchange the air with the outside, and you're just using the heat that you've already produced and not wasting it to the outside. And then you can just ventilate for your moisture control rather than having to ventilate to bring the heat in and bring it down to the floor and all that other stuff. So it's actually sort of using a tool that's designed specifically for mixing the air and improving the uniformity of the air quality in the litter in the shed. So I'd say you probably won't achieve the same thing with mini vents. You really need to have an additional system.
With your field trial work, did you look for an association between air circulation and foot pad dermatitis?
Thank you, Michael. I haven't, like I said, I haven't been involved in actually being able to test the circulation fans in a chicken shed. My calculations, what I showed today was all based on simulations, but I suspect that having the lower moisture content or reducing the peak moisture content in the floor should have an improvement on reducing foot pad dermatitis. But I don't have data specifically to address that.
Mark, how much work's been done with stirrer fans in breeder production?
There's been very little done on stirrer fans in any meat chicken production. Personally, I think the breeder sheds would be a fantastic place to use the stirring fans. With lower density in the shed, particularly in rearer sheds, it would help to improve the uniformity and the air quality in the shed, and having the litter in there longer. By maintaining the litter moisture content lower, I think you probably reduce the the potential risks associated with ammonia in the sheds. And with smaller sheds, the ones I've seen don't have ceiling baffles. To me, it's a much better place to invest in some circulation fans, or it'd be a great place to invest in some circulation fans to improve the conditions and the uniformity of the conditions. So while there's no data to support it, I think breeder sheds would actually be a fantastic place to put the circulation fans.